Hello, sixth grade. Welcome back for another week. We are going to, let me start on your homework board for the week. We are going to cover the remainder of 7-2 and 7-3 this week. So I believe after this week we'll be halfway through the chapter. For this evening, I have posted the images of your book for the part of 7.2 that I'm going over today, the second half of 7.2, as well as 7.3. So make sure that you go online and read and highlight and annotate what I have on my pages. And then the other part of the assignment I'll show you in a moment after we go over it, but we're going to be finding, or you're going to be finding, heterogeneous and homogeneous mixtures in your home. So let's get started. We left off last time with what is a mixture. So if you remember, the lecture that you did last Monday talked about how different molecules formed, and you guys did your molecules, which I'm going to take a look at tomorrow while you're doing this. I will be doing that. So you guys were looking at how do molecules form, and some molecules, remember, are compounds if they are composed of more than one element. But a molecule is always going to be two or more atoms bonded together with a chemical bond. And then we left off on this notion of a mixture. So first of all, let's look at a mixture. What is a mixture? A mixture is simply made up of two or more substances. And they are together in the same place at the same time, but their atoms are not chemically bonded. So a mixture is different from a molecule in that when you chemically bond atoms in a molecule, say for instance with water, when we bond two hydrogen atoms with an oxygen atom and it becomes a molecule of water, the characteristics of that molecule are different than the characteristics of the atoms that make it up. So hydrogen and oxygen are both gases at room temperature, but water, as you know, is a liquid. So when they come together, they change into something new. This is different from a mixture. As you can see here, here's some examples of mixtures. So here we have a mixture of M&Ms. You have coffee, some trail mix, jelly beans, a salad, and some soup. So in each of these situations, you can see that even though we are mixing these things up, even though these things are together in a grouping, their individual identities have not changed. These are still different colors of M&Ms. It's not like by putting them together they form some new substance like we did with hydrogen and oxygen forming water. So each substance that is in a mixture is going to keep its own properties. The atoms are not chemically bonded. And depending on the type of mixture, you may question this, but different from a molecule. In a molecule, remember we said that there's a set ratio of how those atoms are bonded, right? When I make water, I always have two hydrogens for every oxygen. And if it's a different ratio, it's no longer water. Well, when it comes to mixtures aren't really in a set ratio like that. So if I look at this mixture of M&Ms, it doesn't really matter how many reds or blues or yellows or greens I have, and each time I get a bag of M&Ms, I'm going to have a different combination or ratio of colors, but it's still a mixture of M&Ms. All right, and so then we talk about what are two different types of mixtures. A heterogeneous mixture is one in which you can physically see the different parts. So in this trail mix, we have some M&Ms, we have some cashews, almonds, coconut flakes, raisins. These maybe look like cranberries. And I can see each individual piece and I can separate them out. In a homogeneous mixture, the substances that make it up are evenly mixed together. So I can't see the different parts. So this is an example of a homogeneous mixture of pudding. And we know that pudding is made up of, depending on the flavor, it's made up of different substances, milk and sugar, along with other things. But I can't individually see those parts of the mixture like I can with the heterogeneous mixture. And so it's not as easy to see what makes up this substance, what makes up this homogeneous mixture. All right. So how can I separate a mixture? Well, your book talks about 4 different ways that you can use to separate a mixture depending on what your mixture is made up of. That would help you decide which method to use. So magnetic attraction, if for instance you have some metal in your mixture, you could use a magnet to separate out the metal. Evaporation. So we talked a lot in this class. We brought up the concept of a salt solution a lot. And if you remember correctly, a salt solution is going to be when I have salt, which is sodium and chlorine atoms bonded together, and I put it in a cup and I pour in some warm water and I stir it up. And the chemical bonds that bring salt together, bring a salt molecule together, are broken. And so I have sodium atoms and chlorine atoms floating around in my warm water. But eventually, and we've talked about this, when that water evaporates, the salt's going to reform along the side of the container. So the salt didn't change into anything else. It will reform once that water leaves the container and just the salt is left. So that would be using evaporation to get a substance out of solution. Filtration talks about pouring a liquid through a filter and collecting the solid parts in the filter. And then distillation talks about separating liquids. So when I distill something, I boil one liquid to the point at which it's a gas, and then I allow that gas to cool in a separate chamber, and eventually that cooled gas that has boiled off of the one liquid and cools in the separate chamber will reform. The temperature will decrease and it'll reform into liquid. But now typically that second chamber, and your book shows a good image of this, and actually I could probably bring it up because I think this is our last slide. Yes. So let me slip over here to your classroom, and let me just bring up that image of distilling because it'll be easier for you to see what I'm talking about. But basically what happens is you have 2 liquids in here. One boils at a different point than the other. This liquid, as it boils and becomes vapor, is going to come up here and it's going to collect in this tube. And as it moves its way down the tube, it's going to cool and reform into its liquid. And then the other liquid is collected here. So that's one way to separate out 2 liquids that are in a mixture. All right, so let me move on to the next, your assignment. So your assignment for this week is on Classroom. I've posted this homogeneous and heterogeneous mixture example, and I gave you, someone already turned it in. I gave you my examples. And so what you're going to do is you're going to find your pantry or somewhere else in your house. Anywhere in your house. You can find mixtures in other parts of their house beyond the pantry. But you're going to give me an example of homogeneous mixture. So you're going to tell me what it is. And then you're going to take a picture and you're going to upload it. And then you're going to tell me what the heterogeneous mixture you found. And you're going to take a picture and upload it. And you can just insert your image in the cell using this insert image. All right. Save it onto your drive. That's probably the easiest way to put the image on your drive and then just upload it into the cell. All right, so that's easy enough and we'll have a nice collection. And like I said before, on the assignment, do not touch other people's work. I can see if you've messed with other people's work. Just do your own and try to find ones that are maybe other people haven't found yet. So we have a nice collection. All right, let's see where I'm at time-wise. Ooh, I'm running short. All right, I am going to, you know what, I'm just going to cover 7.3 when I have you guys on Thursday. I was going to start 7.3 today, but since I only have a couple minutes left, I don't want to race through it, and I'm seeing you live for our Zoom session on, not Thursday, on Wednesday. I'm seeing you for our Zoom session on Wednesday, so we'll just go over all of 7.3. The beginning of 7.3 is going to be a review from something we did earlier in the year with mass and volume. And so we should get through that pretty quickly, and then we'll go through the density portion of the chapter, which then you'll have an assignment with that part. But that's it for today. So I'm going to let it be with just 7.2, finishing up mixtures. Complete this assignment. And then I also posted the Achieve article early. So this week is the Science Achieve week. And I decided rather than posting on Thursday, I would just post it on Monday. And then you guys have all week to complete it. So whenever you have time to get the Science Achieve done, get it done. It's going to be due by 3 o'clock on Friday. All right. Have a good rest of your day, guys. I will see most of you hopefully on Wednesday in the Zoom. Bye.